Welcome everyone to this video. First question which we are going to do is question number 4. This question came in JEE Advanced 2019 and belongs to chapter of nuclear physics. Question is, we have potassium nuclei. Now that potassium nuclei is going to decay into two separate nuclei. One of them is calcium. The disintegration constant there is 4.5 into 10 to the power minus 10. The other being argon. Its disintegration constant is 0.5 into 10 to the power minus 10. Question is when the sum of these two nuclei, that is calcium plus argon, is 99 times the remaining potassium nuclei, then how much time has gone past? So this question belongs to the category of a billion years. If you see, the time required is 10 to the power 9 years. How do we proceed here? Writing the fundamental equation, how much nuclei are remaining, would be equal to the initial nuclei n naught e to the power minus disintegration constant lambda for calcium into time plus n naught e to the power minus lambda argon into time. So that means that there is a fraction of nuclei that is getting decayed into calcium and argon, but overall both are responsible for the decay. And how much decay is happening is directly proportional to the initial number of the nuclei. So n naught is basically part of both of the equations and their respective disintegration constants, lambda c and lambda a. So if we add this equation, then if 99 nuclei has decayed and only one nuclei is remaining, so we can say that initially there were 100 nuclei, of which 99 have decayed into calcium and argon, and the remaining nuclei is only one. So this equation we can write as one remaining nuclei, 100 original nuclei is equal to e to the power minus lambda c plus lambda a, which is some 5 into 10 to the power minus 10 into the time t. So that is the whole question which I wanted to explain. Basically, what is happening is the potassium is decaying into calcium and argon in the ratio 9:1. If you take the ratio of disintegration constant, in that ratio the nuclei gets decayed. So even though the decay is distributed into two different nuclei, the thing being decayed does not care how much or in which species I'm decaying into. It cares that what is the disintegration constant. So I'll just add up the disintegration constant of both the nuclei. I'll get the final result. Upon calculation here, you will get the answer. You will get something like a 5 into 10 to the power 10. 10 to the power minus 10 is equal to some ln 100. T into this is equal to this. So this becomes some 4.6 divided by 5 into 10 to the power 10. So this comes out to be some 9.2 into 10 to the power 9 years. So option B. So thank you for joining.